The age of artificial intelligence has trickled into our daily lives, with large language models, LLMs, like ChatGPT and Grok, transforming how we interact with technology. But this revolution comes at a cost measured in gigawatts of electricity and millions of gallons of water. The data centers and GPU clusters used to train these AI models are energy hogs, consuming power on a scale that rivals entire cities. In this video, we delve into the shocking power consumption of AI, exploring the energy demands of leading tech companies like xAI, Meta, Microsoft, OpenAI, and Amazon. Before we dive into the energy consumption of these tech giants, let's first establish a basic understanding of the units used to measure electricity. Watt, the basic unit of power, representing the rate at which energy is used or transferred. Think of it as the flow rate of electricity. Kilowatt, 1,000 watts. Most household appliances, like refrigerators and washing machines, are measured in kilowatts. Megawatt, 1,000 kilowatts or 1 million watts. This is the scale at which we start measuring the power consumption of data centers. Gigawatt, 1,000 megawatts or 1 billion watts. Large power plants like nuclear reactors are measured in gigawatts. Kilowatt hour, this is the unit of energy used to measure electricity consumption over time. It's what you see on your electricity bill. xAI, a gigafactory of compute. Elon Musk's xAI has made headlines with its Colossus supercomputer in Memphis, Tennessee. Housed in a former 750,000 square foot Electrolux factory, roughly the size of 13 American football fields, this facility boasts 100,000 NVIDIA H100 GPUs, with plans to expand to a staggering 1 million GPUs. This massive computing power comes with an equally massive energy requirement. Initially, Colossus was expected to consume 150 megawatts of electricity. However, with the planned expansion, power demand could surge to over 1 gigawatt, equivalent to a nuclear power plant. To put that into perspective, supplying Colossus could require the equivalent of building a new nuclear or combined cycle methane-fired generating station just to meet the needs of one customer. To illustrate, a 1 gigawatt nuclear power plant can supply electricity to approximately 876,000 households annually, assuming an average household consumes 10,000 kilowatt hours per year, and the plant operates continuously at full capacity. This raises concerns among Memphis residents, who worry about the strain on the local power grid and the possibility of subsidizing xAI's energy costs. Adding to the complexity, the xAI data center is located in Boxtown, a community in southwest Memphis. This has brought to light concerns about the historical treatment of the area by corporations and the potential for xAI to perpetuate those patterns. Currently, when running at full power, the facility relies on a combination of grid power and portable gas-powered generators to meet its energy needs. The use of these generators has raised concerns about air quality and greenhouse gas emissions. xAI's development of advanced artificial intelligence will require significant electrical power for computation, similar to other leading AI labs. However, accurately forecasting its future energy consumption is challenging. Key details about the eventual scale of its operations, hardware efficiency, and project scope are not yet public, making long-term predictions speculative. Meta's reality check. Fueling the future, counting the cost. Meta, the force behind Facebook and Instagram, is betting big on AI to power everything from your feed to the future metaverse. This means colossal infrastructure spending. $65 billion planned for 2025, including a data center potentially sprawling across a chunk of Manhattan and aiming for over 1.3 million GPUs. A $10 billion, 4 million square foot AI data center is also planned for Louisiana. This AI push translates directly to energy use. Meta's data centers devoured nearly 15,000 gigawatt hours in 2023, a 34% jump from the year before, with leased facility usage almost doubling. Its Prineville, Oregon campus leads consumption. This surge is outpacing employee growth and revenue, signaling AI's heavy energy toll. Meta aims for net zero emissions across its value chain and water positivity by 2030. Since 2020, it has matched its operational electricity use with 100% renewable energy, becoming a top corporate buyer with over 11,700 megawatts contracted. Nuclear energy is also being explored. Partnerships ensure new data centers, like one in Minnesota, run on renewables. Efficiency is key. Meta's data centers boast LEED Gold certification and an impressive average PUE of 1.09 in 2023. PUE stands for Power Usage Effectiveness. A PUE of 1.09 basically means that they are incredibly energy efficient in their daily operations, wasting very little electricity. New AI-optimized facilities will use dry cooling to slash water use. AI itself is being used to optimize energy and water management, and even reduce carbon in construction materials. Meta is also developing its own energy-efficient AI chips, MTIA series, to power models like Llama 4, which trains on massive GPU clusters. The challenge remains balancing explosive AI growth with sustainability goals. Meta's carbon footprint has risen despite efficiency efforts. The company invests in carbon removal and plans future data centers with liquid cooling. Meta also participates in initiatives like DC Flex to find grid-friendly data center solutions. Overall, though Meta tries to minimize environmental impact, the sheer scale and rapid pace of their data center constructions make it really hard to not adversely affect the environment and carbon footprint. Microsoft's Cloud Atlas, charting a sustainable AI course. Microsoft, a tech titan, is deeply embedded in the AI revolution, especially through its partnership with OpenAI. This leadership role comes with a hefty energy bill. Microsoft's electricity use doubled from 2020 to 2023, hitting 24 terawatt hours, largely thanks to Azure powering AI training and operations like ChatGPT. This AI surge contributed to a 30% rise in Microsoft's emissions since 2020. To fuel its AI ambitions, Microsoft plans an $80 billion data center investment for fiscal year 2025. The rumored $100 billion Stargate supercomputer project with OpenAI could demand a staggering 5 gigawatts by 2030, highlighting future AI's immense power needs. Projections suggest Microsoft Copilot and OpenAI's combined energy use could rival a small country's annual consumption by 2027. This growth faces scrutiny, with shareholder concerns about AI support for the fossil fuel industry potentially conflicting with sustainability pledges. Microsoft's response involves ambitious green goals, carbon negative, water positive, and zero waste by 2030, plus protecting ecosystems. It aims for 100% renewable energy for data centers by 2025, having already contracted over 20 gigawatts. Azure is touted as up to 98% more carbon efficient than traditional data centers. Nuclear energy, including small modular reactors and fusion, via a partnership with Helion, is also being explored. Data center design is evolving. Microsoft is developing water-free cooling using chip-level solutions. Low-carbon materials like cross-laminated timber are being used in construction. Circular centers aim to reuse server hardware. A $1 billion climate innovation fund backs clean tech. AI itself optimizes data center energy use, achieving low PUE scores. Looking ahead, Microsoft acknowledges AI makes its green goals harder. It's investing in AI for sustainability, optimizing wind farms, predicting wildfires, and improving biodiversity data collection. Minimizing resource use, expanding clean energy access, and advancing responsible AI policies are priorities. While committed to renewables, Microsoft pragmatically considers natural gas with carbon capture for near-term needs. Microsoft's path underscores a core AI dilemma. Massive energy needs demand equally massive sustainability innovation. Google and Amazon's green challenges, the AI energy tightrope. Amazon's AWS is the engine for much of the world's AI, priding itself on infrastructure up to 4.1 times more efficient than typical setups. Yet future AI could need city-scale power, 1 to 5 gigawatts per model. Amazon is investing massively in 2025 to meet this demand, wielding its capital to build the necessary AI infrastructure. Their power strategy includes custom energy-efficient AI chips like Trainium, alongside being the world's largest corporate buyer of renewable energy, targeting net zero carbon by 2040, and even exploring SMRs. This is Amazon using its might to scale AI and control its efficiency. Google weaves AI into its global empire, driving massive growth with a planned $75 billion AI investment in 2025. This AI leadership has a steep energy cost. Its data centers used around 24 terawatt hours in 2023, with emissions and water use for cooling surging. This demonstrates the sheer scale of resources Google commands. Despite this, Google pushes for sustainability with hyper-efficient data centers, some cooling boosted 40% by its own DeepMind AI, and powerful custom hardware like Trillium TPUs. They're investing $20 billion to co-locate data centers with new clean energy, aiming for 24/7 carbon-free energy by 2030, and exploring geothermal and SMRs. Google leverages its immense technological power to innovate solutions. Amazon and Google, two giants defining AI's trajectory. Their power to innovate and build is reshaping our world, but it's inextricably linked to colossal energy needs. Their response is a powerful display. Billions invested in renewables, a race for hyper-efficient AI silicon, and bold moves into next-generation power. They are using their innovation to address the energy paradox fueled by their own AI ambitions and those of other tech giants. As we stand at the dawn of an AI-powered era, the digital glow of progress casts a long and demanding shadow on our energy resources. The silent hum of servers is escalating into a roar of consumption. By 2025, it's projected that AI data centers alone will demand 200 terawatt-hours of electricity globally. To put that into perspective, that is more than the entire annual electricity consumption of countries like Denmark, Ireland, and Greece combined. This isn't just powering a few extra servers, we are fueling a machine that, according to the International Energy Agency, will soon have an energy appetite rivaling that of entire industrialized nations like Japan. So, as we marvel at the next AI creation, it's worth remembering the colossal, unseen effort behind it, an energy footprint that's pushing our global power grids and our planet into uncharted territory.